Welcome to integration 7, and we start off with trying to do an integration by substitution. So we've been given the substitution, and at first glance it doesn't appear to have a whole lot to do with this. So let's just see where it takes us. So we've got u here. Let's find out what du by dx is. And du by dx, if u is tan x, then when you differentiate tan x, you get sec squared x. So that means that dx is equal to du over sec squared x. So we can put that in. So that means we have the integral here of sec to the power of 4 x times du over sec squared x. And that's clearly going to simplify into sec squared x du. And now we can see that, well, maybe we've got something going here. How are we going to get sec x and tan x related? Well, that's a Pythagorean relationship. So if we consider sine squared x plus cos squared x equals 1, and we divide through by cos squared x, and that gives us tan squared x plus 1 equals sec squared x. So we can turn a sec squared x into a tan squared x here, which is obviously going to help us. So what we've got here is the integral of tan squared x plus 1 with respect to u. Now, if u equals tan x, then u squared is equal to tan squared x. So we've got here u squared plus 1 du, which we can now actually integrate, as you probably realise. So that's going to be u to the power of 3 over 3 plus u plus c, which gives us tan cubed x over 3 plus tan x plus c. Now, hopefully you know that to integrate the ln you need to use the integration by parts formula. So that's what we're going to do here. U is ln of x, which means du by dx is 1 over x, and in this case v is going to be 3, sorry dv rather, dv by dx is equal to 3, which means that v equals 3x. And there we go, off we go from there. So it's uv, so it's 3x ln of x minus v du. So that is the integral of 3x times 1 over x with respect to x. And they obviously cancel. So that is 3x ln of x, put the modulus signs on, minus the integral of 3 with respect to x, which gives us 3x ln of x minus x plus c. Job done. Okay, so a trig one. So we're going to start off by multiplying these brackets out. So that's clearly the integral of cos x minus sec x times cos x minus sec x with respect to x. So we get from that the integral of cos squared x minus 2 cos x sec x plus sec squared x with respect to x. Now, to do the cos squared x, we need to use a double angle formula. In particular, cos of 2a is equal to 2 of cos squared a minus 1, which of course means that cos squared a is equal to cos of 2a plus 1 all divided by 2. So that's what we're going to substitute back here. So we've got the integral of cos 2x plus 1 all over 2. Now, sec is 1 over cos, so these two things cancel basically to give you 1, and 1 times 2 is 2. And we'll keep our sec x, sec squared x, because we know that that's going to integrate quite nicely. Right. So what we've got here is something we can split up. We've got the integral of a half cos 2x plus a half minus 2 plus sec squared x with respect to x. And that can simplify further. A half of cos 2x minus 3 over 2 plus sec squared x dx. Right, let's get actually integrating now. We're ready for it. So we've got a quarter of sine 2x minus 3 over 2x plus tan x plus c. And there we go. Notice I didn't actually integrate until I was ready to integrate every single term. If you start integrating one bit but not another bit, you're very likely to get yourself confused. Okay, last one. Integrate 3 over 1 minus 4x. Well, it's about as simple as they come. This is an ln problem, this one is. So you can take out the 3 if you want. This makes it a bit more obvious. 3 over 1 minus 4x dx. And that's going to be 3 times 1 over minus 4 of ln of 1 minus 4x plus c. So it's minus 3/4 of ln of 1 minus 4x plus c. And there we are, we finished the next one, or the last one.